Hello everybody, this is Horn Frog Engineering, and for this problem we're going to be using a problem from a textbook called Engineering Circuit Analysis by William Hayt. I think I'm going to butcher his name, that's how you pronounce it. It's the 10th edition, and this is exercise 3.56 from page 82. First we're going to solve it using mesh analysis, and then on the back we'll solve the same problem using nodal analysis and just compare the two. For some problems, mesh analysis is probably better than others, and then for some problems, nodal analysis is probably going to be better. So we're just going to compare the two and do a little bit of a commentary at the end to give you guys my opinion and which one I think is better for this problem specifically. So let's get started. We're going to try to find the values for I1 and I2 and V3. Those are the three values that the textbook wants us to find. But first, we're going to need to define the mesh currents. So since this is already defined as I1, I'm just going to call this part I1. And since this is already defined as I2, I'm going to call this mesh I2. And then I'm going to call this mesh I3. And then this mesh right here is going to be I4. Usually it's good to do your mesh currents clockwise. You could do it counterclockwise, but usually it's taught that you should do it clockwise, and that's what I'm used to. If you wanted to do this counterclockwise, you could, but also because the branch currents for I1 and I2 are already going on the right, going towards this way, the right, I'm just going to define it as clockwise, and that's probably what I'm going to do all the time anyway. So the first thing that you notice here is I4 is already defined for us. Well, first of all, we're going to have 5 or 4 unknowns, and this is not really unknown, but let's just pretend I4 is an unknown. So we have 1 unknown, 2, 3, 4, 5. So we have 5 unknowns, which means we need 5 equations. So we're going to pretty much take those 5 equations and use the TI calculator to solve all 5 equations simultaneously. But the first thing that you notice here is I4 is our first equation. I4 is equals to 25 amps. So I'm going to put a box on that and put that equation number 1 with a circle. And then next thing that you're going to notice also is, without doing any mesh analysis yet, well, let's go do the mesh analysis. So we're going to do mesh 1. KVL. So mesh current, again, recall, is based on KVL, not KCL. So we're gonna do a KVL around this loop right here. So it's 1 ohm, which is just 1 ohm, and you always wanna your current that you're gonna put here is always gonna be the current that you're doing a mesh with. So it's I1 minus I4. Since I1 is going that way and I4 is going this way, it's going to be minus. This is your resistance times your currents, and that equals your voltage. Again, mesh is based on KVL, so you want this whole term right here to equal voltage. This is your resistance times your current, which is voltage, plus your 2 ohm right here. Again, you always want to start with the mesh current that you're doing the mesh on, or sorry, I put I4. It's I1 minus I2 equals to 0. And if we simplify that, I encourage you guys, by the way, to follow along with me, write down the circuit, draw it, and also do the work yourself, because if you're just watching me do this, and it might make sense to you while you're watching it, but then when you do it, it might not make sense. So I encourage you guys to follow along and do this with me. So now we're just gonna, I guess, distribute the 1, I1 minus I4 plus 2I1 minus 2I2 equals to 0. And then combining like terms, we're going to get 3I1 minus 2I2 minus 1I4 equals to 0. And that is our second equation. And you want to be very detailed. Usually your professors will want you to show these details, even if you got the right answer at the very end. But if you don't show any details, I know my professor did not give us credit for that if we didn't show this detail. So this, I got equation 1, equation 2, and I need to do an equation now for mesh 2. So now I'm going to write mesh 2 KVL, and then we're going to start off with our 2 ohm. And then again, you're going to lead with your mesh current that you're on, which is I2 minus I1, since I2 is going that way, and then I1 is going opposite direction, is minus I1, plus 5 I2 plus 4 I2 minus I3, and that equals to 0. And then we're going to distribute and combine like terms later. And then combining like terms, we'll get our third equation, minus 2I1 plus 11I2 minus 4I3. You always want to double check, make sure that you have the proper work. It's so easy to make mistakes if you're going fast. And so again, I'm double checking, minus 2I1, 2 plus 5, 7, plus 4, 11, 11I2 minus 4I3. And that gives me my third equation. I need 5 equations because I have 5 unknowns. Now we're going to do our mesh 3 KVL. So now we're going to be in this mesh right here, which is going to start off with our 4 ohms, which is I3 minus I2. I guess you always want to lead with the mesh that you're on. I3 minus I2, and it's minus I2 because I2 is going the opposite direction, plus 4 I3. It's just I3 on this 4 ohm resistor. And then also, same thing, 4 I3. So now we're going to distribute this 4. You want to take it, you could easily skip this, and instead of doing the distribution and doing it step by step, it's easy for you to just skip it, and then hey, you may or may not mistakes. But I find myself, if the more steps I skip, usually the higher chance that I'm going to make mistakes. So I like to be very detailed and not skip any steps. And also shows that the professor that if you make mistakes, he might give you grace. If you do it step by step. We're going to combine our like terms. It's minus 4 I2, and then we have these 3 I3s, 4, 8, 12, plus 12 I3 equals 0. I'm going to box that, and this is going to be our equation number 4. And now you look to see that, okay, you have this for I4, you have this for mesh 1, mesh 2, mesh 3. We need one more equation because we have 5 unknowns, right? So where do I go from here? And this is where a lot of students probably will get lost. But if you look over here at V3, you can use the Ohm's law. to create another equation. So we're going to use Ohm's law at 4 ohm and V3 over here. And according to passive sign convention, this is following passive sign convention, the I3 is entering the positive terminal of the resistor. So you don't need to do any flipping of any signs. So it's just going to be V3 equals 4I3. But if this was going counterclockwise the other way, that means that the I3 would be entering the negative terminal. So this is going to be negative 4I3. But since this is entering the positive terminal of I3 or of V3, this 4 ohm, you don't need to do any negative. You don't need to flip the signs. So because of passive sign convention for a resistor, the passive sign convention is always going to be the current is always going to be coming in from the positive terminal, which resistor doesn't really have any terminal, but wherever the current is entering in, that's going to be your positive side usually. So for this one, there's not going to be any sign flipping. It's just going to be straightforward. V3 equals 4I3 because the current I3 is entering the positive terminal of the 4 ohm resistor, if that makes sense. Hopefully it didn't cause any more confusion with that. So now we're going to switch V3 on the other side, which gives us 4I3 minus V3. And the reason why I'm doing that is I'm going to set up an augmented matrix. And that's going to give us our fifth equation. So now we're going to organize everything, set up an augmented matrix, and solve our system, our five equations simultaneously using the TI-84 calculator. So you have your I1, I2, I3, I4, and then your V3, and then your constant. So let's set up this augmented matrix. This is going to be the right-hand side, and this is going to be the left-hand side. So if you look over here, there's no I1, I2, I3, I4. So it's just going to be 0, 0. Sorry, there is an I4, which is 1. There's no V3. And then on the right-hand side is a 25. For your second equation, it's 3, negative 2, 0, 0 because there's no I3. And 4 is negative 1, 0. Again, you want to go slow. Make sure you double check. Make sure you don't make any mistakes. It's so easy to make mistakes in this part. And then for your third equation, your I1 is going to be a negative 2. You're looking at the coefficients. 11, negative 4. And I4 doesn't have any coefficients. I mean, not coefficients. I4 is pretty much 0. So the coefficient is 0. And V3 is 0 for that one. And then equals to 0. For our fourth equation, it's going to be 0 for I1 because there's no I1, and then we skip to I2, which is negative 4, and then 12, 0, 0, 0. And then for our fifth equation, there's no I1, there's no I2. There is, however, an I3, and then a 0, and then a negative 1, and then a 0. So if you put this into our matrix, we're going to set up an augmented matrix. Go to second, matrix, edit, and this is a 5 by 6 matrix, 5 by 6, I already have it on there. And then you're going to input all of your values one by one. And I already did it beforehand. So whenever you do that, you're going to go back to second matrix, go to math, go down to RREF, and then go to second matrix again, and you're going to want to enter in matrix A or whatever matrix you use. In this case, we use matrix A. And then you're going to get your answers. This is going to be your I1, and then your I2, I3, I4, and V3. So we're going to write that down, and it's asking for, the question is asking for I1, which is 9.67 amps. I2 is 2.00 amps, and then V3 is 2.67 volts, not amps. So be careful with your units. And that is your answer. And this is using mesh analysis. So with mesh analysis, you're going to have 5 equations with 5 unknowns. Just to recap, I chose I1 for this mesh right here because I1 is already defined by the branch current on this one as I1. So I didn't want to confuse myself and set this up as I2 or I3 or something different. So you have your I1, I2, I3, I4, your V3. So that's 5 unknowns, which you're going to need 5 equations. So we have equation 1, 2, 3, 4, 5, and then you're going to set up an augmented matrix like this one with your coefficients of the left-hand side and then your right-hand side of the equation on this side. And then you're going to use the RREF function on the car calculator, and you're going to get your answer. Now let's go on to nodal analysis and do a comparison to see which one is better for this problem.